A special good morning to all those who are present here. My name is Suraj Kumar Pradhan, working as an application engineer at Karma Software Limited. So today we are going to discuss about the simulation, how to do the assembly simulation, then how to compile that one and do the replay. Then if there are two simulation in an assembly or in an DMU kinematics, at that time how to do the simulation, how to make it as a sequentially, that we are going to learn today. So here the most important thing is class. So while doing the simulation we can check the class. We are you will get the contact analysis, contact, here you will get the class. We will identify with the help of class tool while doing the simulation. Then the next tool is swept volume. In that swept volume, if you have, for example, if you have the simulation and you want to see that simulation in a volume, in the form of volume, at that time we will use swept volume. Then we will going to the next tool, that is trace. Trace is nothing but to define the path of the simulation. Okay, what is the path, how it is how it is doing the simulation, that we will know in trace. So without wasting time we will going to one assembly simulation. So for today I have taken for you, that is quick lever mechanism, quick return mechanism. So in that quick return mechanism we will do the simulation, we will do whatever the tool I have discussed now. So as everybody know how to do the joint in in two parts. I hope you get that thing in the previous class. So as everybody know, while doing the simulation our first step is to fix one component. Okay, so here in quick return mechanism I am going to fix one component, the new mechanism, create a new mechanism, type the name, that is quick return mechanism. Okay, and my fixed part is this one. Okay, this is my fixed part. So you can see the mechanism has been defined and the fixed part also defined. Now the main challenges here, how to identify the joints, where we will put the how we will put the right joint between two parts. Okay, so for example, if there are one flat surface and one round surface, how to do that simulation, how to know how what type of joint you will going to use in that two part. So creating the joints is totally depends upon you, how to create the joint, how you will choose the joint. Okay, so if there are two round objects, then in that condition you can use revolute join. If it is rotating in a certain limit, then you can use revolute join. Or if you are getting two round object and you want a translational motion, that time you will choose uh, cylindrical joint. So as you can see in the fixed part and the connect and slotted lever assembly, you can see here there are two round object. Okay, so if there are two round object, we will go with revolute joint in the sense of mechanism. So for revolute joint, I think I no need to explain it, because we had already discussed about this, how to create the revolute joint. Take the line, then your second line, then take the plane. You can make as null offset. Null offset means the offset value is 0, or you can give the offset value. It is total depends upon you how you want to do the assembly. Revolute join, then click OK. Now here we are given revolute joint. Now you can see here in the motor and the crank, motor and crank, these are also two round object. You can go with revolute join. First line, second line, and here it is plane and plane. You can make, you can give null offset or give offset. It's total depends upon it. Okay, you can see here 2 degree of freedom, because we have already here we are not defining 1 degree of freedom, that is rotation. Okay, because as you can see here we have defined two revolute joint. One is here, another is in with respect to the motor. Okay, two revolute joint, but we are not define the angle. If you are giving the angle, then it will be rotate. But in this assembly, we will correlate the joint. Okay, if I will go with another joint with respect to this revolute joint, then that angle will be fixed. So that you will be understand after these joints, you will understand. Okay, now we can see here two plane. Okay, this slider and the lever assembly, it is making planar joint. Yes or no? Sorry, prismatic joint. Okay, because the slider is fixed with this, and it is translationally movement with respect to the lever assembly, slotted lever assembly. Okay, so we will going to do prismatic joint. So in prismatic joint, we will take the line. You can hide this one, this slotted, hide, and take this corner line. Okay, hide. Then we will go with the plane, first plane, and the second plane. As you know, in prismatic joint, you need a line and a plane between two parts. Okay, collinear plane between two parts. Then click OK. we have defined three joints and we are getting 3 degree of freedom. As you can see in the revolute joint we are not defining the angle driven. Okay, in the second revolute joint also we are not defining the angle joint. Okay, then we are not restrict the length because it need to be rotate. Okay, then only mechanism is possible. Okay, now comes to this. Now we can see here in the connecting rod and the slotted lever assembly, these two also making it is a rotational movement, so it is a we will apply here, we will create revolute joint between these two parts, connecting rod and slotted lever assembly. First line, second line, hide this one, first plane, you can this surface give offset value. Okay, now mostly now we can see here the connecting rod and the cutter slider, these also moving. So what type of joint it required? As you can see here, two round object is there. Okay, round parts is there, so we will go with the revolute joint. First one, second one, first one, cutter height, display, right click, I done so, give the offset value. Okay, okay. Is there any doubts up to this? Okay, thank you. Now we have defined nearly five revolute joint. Yes or no? 5 joints, and we are getting 5 degree of freedom. Don't worry about the degree of freedom. While if you give any command at that time, the revolute joint will be the degree of freedom will be restricted. And you can see here in the crank and the slider, it has one joint. What type of joint we will apply here? You can see it is also rotating, so you will apply here a revolute joint. Okay, first one, second plane, then click OK. First, second, I done so. Okay, you can see I done so. You can see we are creating another revolute joint. Okay, now you can see here we have created a prismatic joint. Okay, so while doing the prismatic joint, we have 1 degree of freedom left. So after connecting this prismatic joint with this revolute joint, 1 degree of freedom removed. Okay, similarly here with your motors and the crank, we are creating 1 revolute joint, and that also 1 degree of freedom. While creating this crank and the slider, why after creating the crank and the slider joint, this degree of freedom also restricts. Now these are connected to each other. Now we will go with the this one. Go with this. Okay. So you can see the cutting slider and the fixed object. Okay. These are, it is what type of joint we will apply here? That is your planar joint. So for planar joint, what is your requirement? We need to coplanar plane. Okay, surface. So this is my first plane. Then I will hide this fixed object. Then this is the second. Okay. Alright. Then click OK. Now you can see how many degree of freedom you have now. You have only 1 degree of freedom because previously it was 3 degree of freedom. Okay. So here, how the 3 degree of freedom? Here you will get 1 degree of freedom. Okay. Here you will get another degree of freedom. Okay. And here you will get another degree of freedom. So 3 degree of freedom you are getting. Okay. Now these 2 degree of this here, this revolute joint and this revolute joint is fixed with the, means related with the another joint, that is planar joint. Okay, this planar joint. Okay, now we have only 1 degree of freedom, and if you will give the angle driven means what revolute joint will apply, this motor angle driven, click OK, then mechanism can be simulated. Okay, up to this any doubts? Okay, fine. Now we will animate that simulation. Okay, we'll go with the simulation. So what is our simulation object? That is quick return mechanism. Click OK. You can see it is moving. So you can see here up to this it is minus 237. We need this much. Okay, need this much. We don't want to outside. We need only minus 2. Okay, 260. Let the limit is between 260 minus 260 and minus 260. To 0. Okay, and 260 to 0. So how will change that one? We will go with that one, that revolute. Here we will apply the command minus 260 and here it is 0. Okay, now we can simulate that one, that mechanism. Then insert, again forward, insert. We have 2 motion and we will apply the loop. You can apply your animated view, animate viewpoint, decrease the speed. You can see how the mechanism is simulated. Okay, now automatically if you don't want to do the simulation manually, so at the time you will go with automatic insert. While playing that command, it will automatically take in the recorder. I will make this speedily. You can see. While I am inserting automatically, you can see here. While inserting automatically, how many steps it has taken? 140 steps. But if you do in manually, that also okay. But if for more accurate, you need to do automatic insert. Okay, it is total depends upon you how you are going to do the simulation. Okay, so click OK. After OK, you will get the simulation. Okay, you will get the simulation. So now I am going to tell you how to compile the simulation. Okay, compile means that is replay. We will create the replay. Whatever the simulation we are playing, that we will replay that one. Okay, I will take that one 0.01, animate the view, click OK. You can put the time step is 1 second. See, it is this compile simulation. It is total depends upon your or simulation. Okay, simulation speed, how much you have given, how much step it has taken, that is depends upon your simulation. So it will take more time to do the compile simulation because we have 140 step. Then click OK. Can go with the compile simulation with one animated view. Click OK. In 1 second, that's created. You can go with no need to click the simulation and do the simulation and all. We can directly replay here. Double click, then do the simulation. Okay, you can go with the animated view. How it is doing the simulation. Then we will whatever the simulation we have created to generate the animation file in VFW. Recorder, create the file, let it record video, click OK. That's something we will get in video file. Okay. I will check with that video file. Go with that video folder. You can see here video recorded file. As you can see, we are getting the video. I think this that's no doubt. I hope you my fun. Thank you all.